In this video, we're going to introduce arc length. So we've talked about an arc before, right? It's the part of the circle that is intercepted by a central angle. Well, now we're going to talk specifically about the length of that arc. The length, which we use the variable s to represent arc length, the length s of an arc intercepted on a circle of radius r by a central angle of measure theta is given by the formula s equals r times theta, where theta is in radian. All right, so we've got our central angle here, and it cuts this arc. And if we want to calculate the length of that arc, we're going to use this formula, S equals R times theta. That's a formula you need to know. But what's critical with arc length is your theta has to be in radian. It's the only way the formula works. So if you have an angle given in degrees, the first thing you have to do is convert it to radian before you can plug it into your arc length formula. So let's find the arc length, and we'll round our answer to the nearest hundredth. They've given us a radius of 12 centimeters and an angle of pi over 2. That pi is a dead giveaway that it's in radian. Plus, it doesn't have a little degree circle to indicate that it's in degrees. Our arc length S is going to be equal to R times theta. So that's going to be 12 times pi over 2. Oh, this is going to give us 12 pi over 2. If they wanted an exact answer, we'd say 6 pi, but they asked us to round to the nearest hundredth, so we're just popping that into our calculator. Again, using the pi key, not 3.14, and rounding to the nearest hundredth, we're going to get an arc length of 18.85 centimeters. Let's take a look at our next example. We want to find the arc length where the radius is 100 feet and our angle is equal to 60 degrees. So right away, I notice that the angle they've given to us is in degrees, and we absolutely must convert this to radian before we can plug it into our formula. So to convert to radian, we're going to take that 60 degrees and multiply it by pi over 180. We can do a little simplifying first. 60 goes into 61, 60 goes into 183 times. This angle becomes pi over 3 in radian. So now our arc length S is going to be equal to R times theta. So that's 100 pi over 3. And we'll put that into our calculator and round to the nearest hundredth. We get an arc length of 104.72, and our unit is feet. In our next example, they've given us the radius and the arc length, and they'd like us to find the central angle theta in radian measure. We'll round to the nearest hundredth if necessary. We're using our arc length formula that says S is equal to R times theta, and I'm just going to plug these values in. So we have 30 equals 10 times theta, and now we need to solve for theta. We'll simply divide both sides by 10, and we get that theta is equal to 3. And it told us to leave it in radian measure. Well, that's what our formula spits out, is radian measure. That's the only thing we can plug in. So when it spits out an angle, it's always going to be in radian. So 3 radian. All right, one more. This time they've given us the arc length of 10 millimeters and an angle of 2 degrees, and they want us to find the radius. We're using that arc length formula, S equals R times theta. And we have the 10 to plug in for the S, but the theta, it's not ready yet, right? We got to convert this to radian. We're going to take this 2 degrees and we're going to multiply it by pi over 180. We can do some simplifying first. And 2 degrees is the same as pi over 90 radian. And now we have what we need to plug in. So 10 in for S. R is what we're looking for, times our theta, which is pi over 90. To solve for R, right, we got to get rid of that multiplication by pi over 90. So we'll divide by pi over 90, which is the same as multiplying by the reciprocal. So I'm going to think of it that way. It gives us R is equal to 900 over pi, and we're going to round to the nearest hundredth. We get a radius of 286.48, and our unit is millimeters. In our next video, we'll look at some more interesting applications of arc length.